All right, get ready for a mission that's spark space-age tech, part-time machine, and a whole lot of detective work. We're heading to a frozen alien world to hunt for clues. Clues to one of the biggest mysteries out there.
Yep, we're talking about the big one. How did life even begin? It's the ultimate cold case, right? And the problem is, the original crime scene, right here on Earth, is totally contaminated. I mean, life has been so successful here, it's completely changed the planet's chemistry. It's like trying to find fingerprints at a crime scene after a million-year-long party. All the original evidence, those first chemical steps that kicked off biology, they're just gone. So where on Earth, or off it, do you even start looking? Well, that's where NASA's Dragonfly mission comes in. And you've got to hear how the head of the mission, ZB Turtle, describes it. She says Dragonfly isn't a mission to find life. Nope, it's a mission to investigate the chemistry that came before biology. So we're not looking for little green men, we're looking for the recipe book for life.
Okay, so if the crime scene on Earth is awash, we need to find one that's been left untouched. And that brings us to our prime location, Saturn's biggest moon, Titan. You can think of it as a perfectly preserved prebiotic time capsule. And the key phrase here is prebiotic chemistry. It's a fancy term for, all the chemical stuff that had to happen before life could get going. The cake analogy on the slide is actually perfect. Dragonfly isn't looking for the baked cake. It's trying to find the flour, the sugar, the eggs, and figure out how they all got mixed together in the bowl to begin with.
So what's Titan actually like? Well, in a lot of ways, it's kind of like a primordial Earth, but stuck in a deep freeze. It's got this thick, hazy atmosphere. It has rivers, lakes, even seas. But here's the twist. They're filled with liquid methane and ethane, not water. And the temperature? A bone-chilling -300 degrees Fahrenheit. The amazing part is it's loaded with complex organic molecules, the very building blocks of life, all perfectly flash-frozen for us to find.
And Dragonfly isn't just going to land anywhere. Oh no, it has a very specific target, a place called Selk Crater. This is ground zero. The theory is that a long time ago, something big slammed into Titan right here. The impact was so huge it melted the water ice, creating a temporary pool of liquid water that mixed with all those organic molecules on the surface. For thousands of years, you could have had this perfect prebiotic soup just simmering away before it all froze over again. One of the co-investigators, Sarah Hurst, said it best. She called Titan a long-running chemical experiment on a planetary scale. I mean, think about that. Nature has been running an experiment for us for billions of years, something we could never, ever hope to replicate on a lab back here on Earth.
All right, so we've got our crime scene. We've got our motive? Kind of. Now let's meet the detective we're sending in to crack this case, the Dragonfly rotorcraft. And here it is. Look at this thing. This is not a rover like we're used to on Mars. This is a dual quadcopter, basically a giant drone with 8 rotors. It's built to fly through Titan's super thick atmosphere, hopping from one spot to another to carry out its investigation. And let me tell you, when you see this artist's concept, you might think it's small, but you would be very, very wrong.
Okay, for some perspective, remember that awesome little helicopter on Mars, Ingenuity? That thing weighed about 4 pounds. Dragonfly? It weighs around 1,000 pounds. It's about the size of a small car. This isn't some little hobby drone. This is a nuclear-powered flying science lab. It's packed with instruments that can drill into the surface and analyze whatever chemistry it finds right there on the spot. It's incredible. And just so we're clear, this isn't some far-off sci-fi dream. This is really happening. The engineering work is well underway. They've already tested the rotors in a crazy wind tunnel that mimics Titan's thick, cold atmosphere. They figured out the insulation it's going to need to survive at -300 degrees. They're even building the aeroshell that's going to protect it as it screams through the atmosphere. This is happening right now. So that brings up a pretty big question, right? How in the world do you fly a car-sized drone on an alien moon that's almost 1 billion miles away? Well, that's where the investigation plan gets really clever. And it is a huge challenge. Just think about it for a second. On Titan, there's no GPS. You can't just plug in coordinates. There are no high-res maps to follow. There isn't even a magnetic field, so a simple compass is useless. So, how does Dragonfly even know where it's going?
Well, the main answer is a technique called visual odometry. It sounds complicated, but the idea is actually pretty simple. While Dragonfly is flying, it's constantly taking pictures of the ground below it. Then, its software compares those pictures, one after the other. By seeing how rocks and dunes and things shift from one frame to the next, it can calculate precisely how far it's gone and in what direction. Pretty smart, huh? But what about longer flights? Or if it needs to return to a spot it's already visited? For that, it uses this brilliant system the team calls breadcrumbs. Just like in the fairy tale, it drops digital breadcrumbs along its path by saving important images and their locations. This lets Dragonfly either retrace its steps perfectly or navigate to a new landing spot that it's already checked out from the air.
And this breadcrumb system is key to its two main flight plans. First, you have scout missions. That's where it flies out, explores a new area, and then uses the breadcrumbs to get safely back to where it started. Then you have leapfrog missions. That's where it flies to a new landing site it's already scouted, lands, and sets up a new base of operations to explore from there.
Now, this mission requires some serious patience. I mean, the scale is just epic. Get your calendars out. The launch is currently set for July of 2028. After that, it's a 6-year journey across the solar system. It won't even get to Titan until 2034. And only then will its real work begin, a mission that will last for years, flying to dozens of different locations to analyze the surface.
So, this all brings us back to the biggest question of all. Why? Why go through all this incredible effort, this expense, this decade-long journey? What are the stakes here? What do we learn if we crack the code of life? This quote from another investigator, Morgan Cable, just sums it up perfectly. She says they're like detectives with magnifying glasses, just looking at everything and wondering what it is. It's about pure, fundamental discovery. Scientists are going to be poring over every last bit of data from Dragonfly's instruments, trying to piece together the chemical story that's been frozen into Titan's surface for eons.
When you get right down to it, what Dragonfly is searching for could point us toward one of two incredible possibilities. Possibility 1, life here on Earth was a cosmic coincidence, a total fluke, a 1 in a trillion long shot that needed such specific, rare circumstances that it probably never happened anywhere else. Or possibility 2, the chemical steps that lead to life are actually common. Maybe they're a natural process that happens all over the universe whenever the ingredients and the conditions are right.
And that is what this is all about. By studying that chemistry before biology, by finding out how far down that path Titan managed to get, we'll get a huge clue as to which of those two stories is the real one. Did Titan's ancient prebiotic soup create some of the same molecules that were the precursors to life here? The answer to that question could completely change how we see ourselves and our place in the universe.
Which leaves us with this final, really profound thought. What if life isn't a miracle? What if it's just inevitable chemistry? Is it possible that the recipe for life is written into the very fabric of the cosmos, just waiting for a planet with the right conditions to come along and act as the kitchen? Dragonfly is our detective, and it's going out there to try and find the answer.